beams here. Now this is, so for the column you need the ultimate actual load on that column, and that you need to multiply that by 50. That will give you area of column. And I would recommend to provide a square column because it's easy for you. Okay, so you just calculate the area and then you take a square root of that. That will give you side of that column. Okay, for example, you got the 1600 millimeter square. You know 400 by 400 is okay. Okay, but when you calculate the actual load, the N max capital N, you need to multiply with these factors for the corresponding column. For example, if your column is interior, then you multiply with 1.25. Okay, if your column is H column, you multiply with 1.5. If it's corner column, you multiply with 2. Why is that? Because you are incorporating the bending moment effects. Okay, when it's a corner column, you have the bending, you will be having the bending moment from the both the direction, right? But if you multiply with 2, you are actually accounting for that. So you basically you are considering the actual column only, but these factors actually incorporates bending effects. Okay, now how to calculate the actual load basically. um, if I look, I'm just drawing a plan view of like simple one. Okay, suppose this is my b1 b2. Okay, this is my b1 b2 and this is my other one. Okay, and there would be continuity, there would be here, there, and as well. Okay, but I am looking at this column. What I will do, I will take half of the load, right? Half of the from here, half of the here, and all. So first, this is my beams. You can draw a little bit extra to show that there is, you are considering continuity, but it is not affecting your column. Okay, and you have columns, you have beams here. Now this is my area of load that would be coming. Now to decide the size of the column, obviously I will be taking the bottom most because I will give the same size throughout. And if I calculate the actual force in the bottom one, I will then give the same size. Okay, so if I have 3 floors, 1 2 3. Okay, so example, I have the live load here, 5 kilonewton per meter square, SIDL as 1.5, and dead load, I'm taking a slab, only slab load. No, I'm ignoring the beam one because there's no, you won't be having too much time to do it. Okay, so my slab is 300, so you take 0.3 times 25, 7.5. Okay, total load you take, what's this at 9, 14 kilonewton per meter square. Now you have to calculate capital N. Capital N would be 14 times 3, 1 2 3, right? 3 floors, and then you multiply with 1.5 load factor, not this, not the bending moment factor. When you just multiply with a load factor, right, to increase the load. So this is a factor load, but since it is an interior column, okay, then I will take this factor as 1.25. Okay, I will multiply with 1.25, and you just multiply everything. Okay, this will give you 78.75 kilonewton per meter square. Okay, but you are looking for the load on the column, right? Then you need load in the kilonewton. Okay, so you need to multiply this and with this dimension. So this is 8, this is 8, this will be 8 as well, this will be 8 as well. Okay, so n will be, your final n will be 78.75, 8 times 8, 5040 kilonewton, right? Okay, so once you get that, now area of column would be n times 50, 5040 times 50. How much is that? 25200 millimeter square. Okay, now size of the column would be 500 mm, right? Yeah, right. 500 by 500 is your size.